Welcome to this lecture on first order systems, step response, features of step response. This is a continuation of previous part, that is part 4. Part 4 was done earlier. The video lecture titled as PC37, part 4. So this part 5 is a continuation of that. So for easy understanding, for clear understanding, you should have listened to, you can go through part 4, previous part, and then continue with this lecture. In the previous part, we had found out what is step response, what is a step response equation. That is, how do you find the response equation of a first order system when given a step input. So this is the transfer function of first order step input. Step input and the response equation. This is the response equation. M is the magnitude of the step. M is the magnitude of the step input, and this is the response equation. What are the features? Already we have seen what is the ultimate value. That is, as t tends to infinity. As t tends to infinity, what happens to the response? That is known as ultimate value. So at t equal to infinity, this value yt becomes mk, or yt by mk becomes 1. So this is ultimate value. In the previous lecture, I had explained what is how do you interpret this ultimate value and what is its significance of this number being 1 compared to the step input. So that is the first feature as discussed in the previous lecture. Now we'll see more features of the step response. The link for the previous lecture is given above and also in the description below. Now we'll go for more features. So this is when you substitute t equal to infinity in this equation. What happens for the period, for finite period of time, that is after t greater than 0 onwards? For t 0 onwards, if you substitute any time, what will be the value of this response? For example, if you substitute t equal to tau in this equation, substitute t equal to tau or t by tau equal to 1. So if you substitute t by tau equal to 1 or t equal to tau, you will get yt by nk equal to 0.632. That is, in percentage, 63.2%. Similarly, when you substitute t equal to 2 tau, you will get yt by mk as 0.865, or 86.5%. And 3 tau, when you substitute t equal to 3 tau into this, or t by tau equal to 3, you'll be getting 0.95 or 95%, and so on. So what does it mean? This means, for example, when t equal to tau 63.2 or 63.2% means what? So these values indicate that when t equal to tau, 63.2% of the response is reached. It takes infinite time. That's the first point. It takes infinite time to reach the ultimate value, which is 1. But when t equal to tau, it reaches 63.2% of the ultimate value. That means 63.2% of the response is completed when t equal to tau. So that is the second feature. The response yt reaches 63.2%. 63.2% of the ultimate value when t equal to tau. Similarly, 86.5% of the ultimate value when t equal to 2 tau. Remember, tau is the time constant of the system. 95% is reached when t equal to 3 times the time constant, and 98.2% is reached. 98.2% of the ultimate value, or the 98.2% of the full response, complete response, is reached when t equal to 4 tau, and so on. So practically we can consider, even though it takes infinite time to reach 100% of the response, practically you can consider that 95 or 98 or even 99.3% when t equal to 5 tau. So practically we can consider that the response is completed in about 4 time constants. 4 time constant, that is 98.2% can be practically considered as 100. If we still want more accuracy, go to 5 time constants. So practically we can consider that the response is completed in about 4 time constants, or sometimes even 3 time constant is acceptable. So 3 or 4 or 5 time constants. So that is the practical value of the response. So this is the second feature of the response. So let us see this all these values in the form of a graph, because visual speaks better than words. Well, this is the pictorial representation of these values. This is y by mk. Y by mk is on the y-axis, and t by tau on the x-axis. T by tau being easier to represent in terms of dimensionless parameters. So t by tau dimensionless. Similarly, y by mk. Y by mk is also dimensionless. So plot of y by mk versus t by tau, these two. The second column on the y-axis, first column t by tau rather on the x-axis. So you find that when t by tau equal to 1, the response reaches 63.2%. And when t by tau equal to 2, it reaches 86.5%. 86.5% here. This is 86.5%. And t by tau equal to 3, you get 95% here. And t by tau equal to 4, 98%. And t by tau equal to 5, 99.3. So this value y by yt by mk, theoretically, it will never be able to reach the ultimate value 1 in finite time. In finite time, this will never reach 100% of the response. It is reached only when t equal to infinity. Only when t equal to infinity. But practically, when t equal to 4 tau or 5 tau, when t equal to 4 tau, 98% is reached. When t equal to 5 tau, 99.3% is reached. So that is what it says. Practically, we can consider that the response is completed in about 4 time constants. Tau is a time constant. Well, this is the second feature of step response. Now, third feature. If you look at the figure here, response figure, you will notice that the response begins immediately at t equal to 0. The response begins immediately at t equal to 0. And the slope of the curve, response curve, this is the response curve. This is the response curve. Response curve. The slope of the response curve is the highest maximum at the origin at t equal to 0. As you can see by this tangent. This is a tangent drawn to the curve at t equal to 0. The slope of the curve is the highest or maximum. The response curve has maximum slope at t equal to 0. Slope indicates what? The rate of change. So the rate of change of the response, the speed of the response is the highest at t equal to 0. The response begins at t equal to 0 with the highest speed. If the same speed were maintained throughout, the response would reach the ultimate value when t equal to tau. Got it? The response, in other words, the response would be complete at 1 time constant if the same speed means the speed at the origin at t equal to 0 is maintained. The response will be complete in t equal to tau. So that's what this tangent, this is a tangent, this straight line is tangent. This straight line is tangent to the curve The straight line is tangent to the curve at this is tangent to the curve at t equal to 0. This is the third feature of the response, what we discussed now. The response begins immediately at t equal to 0 with the highest speed. The response begins immediately at t equal to 0 with the highest speed. The slope of the response curve at t equal to 0 as shown in the figure is 1. You can see here when y by mk is plotted t versus tau, the slope of the tangent is, the slope of this tangent is, you can see 1 by 1. The slope of this curve, the slope of the response curve at t equal to 0 as shown in the figure is 1. If the initial rate of change of yt, if the initial rate of change of response were maintained throughout, then the response would reach the ultimate value in one time constant. That means the response would be complete in one time constant if the initial rate of change of response were maintained throughout. But it does not happen because of the lag in the system. Because of the lag in the system, it does not happen, and it takes infinite time to complete the 100% of the response, theoretically and practically about 4 times time constant. So these are the features of step response. First feature is this: the ultimate value is 1. What is the significance? We have seen earlier, previous lecture. And when t, second feature, at t equal to tau, one time constant, 63.2% of the response is completed. 63.2% of the response is completed. That is this. 63.2% here is completed at t equal to tau. Similarly, for other time constants, what are the values? So practically we can consider that the response is completed in about 4 time constants. Second feature. Third feature is this: the response begins immediately t equal to 0. Remember, t equal to 0 is the time at which disturbance is given. The time at which disturbance is given to the environment of the system, surrounding of the system. So the response also begins at the same time as the time at which the disturbance is given. Same time, t equal to 0, and with the highest speed. If the same speed is maintained, the response will be complete in one time constant. Well, these are the features of step response, important aspects of step response. Which we had studied in this lecture and previous lecture. We'll see about other types of responses in the coming lectures. See you.